Hello everyone. As we continue to look at reflection in transformation geometry, I'd like us to look at another example of reflecting in the x-axis. Now, we have here quadrilateral GHFE. Now, we have already gone ahead and obtained the coordinates of each point. But just to be clear, the coordinates of point G are -8, -1. Because if we trace point G to the x-axis, we'll get -8. And if we trace it across to the y-axis, we'll get -1. Point H has coordinates -5, -2. As we can see, if we trace point H to the x-axis, we'll get -5, and to the y-axis, we'll get -2. Point F has points -5, -4. Tracing it to the x-axis, we get -4. Tracing it to the y-axis, we also get -4. And finally, point E has coordinates -7, -4. If we trace point E to the x-axis, we get -7, and if we trace it to the y-axis, we get the -4. Let us bear in mind that we always obtain the x value first, the x coordinate, and then the y coordinate. With that said, we can now move straight into the reflection. As is the concept that was used previously, in order to reflect an object in the x-axis, we know that the x-axis serves as the mirror line. What we need to do is to find out the distance of each point from the x-axis, and we will measure the same distance in the opposite direction to obtain the image of each point. I will do this in purple. So, point G can be seen to be 1 unit away from the x-axis. That is, this is the x-axis, this is point G. From point G to the x-axis is 1 unit. We would therefore go 1 unit in the opposite direction to obtain G prime. That will take us here. Point H can be seen to be 2 units from the mirror line, which is in this case the x-axis. So that is from H to here is 1, and from here to the x-axis is 2 units. So we'll count 2 units in the opposite direction, 1, 2, and that gives us our H prime. Bear in mind that the position of each coordinate is important, so as we reflect them, we will also label them. Then we will reflect point E. Point E is 1, 2, 3, 4 units away from the x-axis. Going in the opposite direction, we will count 1, 2, 3, 4 units in the opposite direction, and there we will obtain E prime. Finally, point F. Point F can be seen to be 1, 2, 3, 4 units away from the x-axis. Therefore, we will count 1, 2, 3, 4 units away from the x-axis to obtain point F. So there we have the image of each point, and that now enables us to connect the dots to obtain the image of the object. Bear in mind, students, that no matter how many vertices or points an object has, we follow the same procedure of measuring the distance from the mirror line to the point to each individual point on the object, and we will measure that same distance in the opposite direction to obtain the points of the image. So even if you get an object that has 6 vertices or points, the concept that is to be applied remains the same. So I'm now connecting my dots using my ruler. And there we have the image of quadrilateral EFGH. Now we will go ahead and record the coordinates of each point of the image. Point E can be seen to be -7, 4. So point E, I'll just put it beside it. -7, 4. Point F prime can be seen to be -4, 4. Point H can be seen to be -5, 2. If you follow the mouse, you will see the direction in which we are, from which we are reading. And point G prime can be seen to be -A1. There we have the image of quadrilateral EFGH. I want us to make an observation. As was said previously, when an object is reflected in the x-axis, the y values change, in that the value that was negative becomes positive and the value that was positive becomes negative. Take, for example, point F prime. Point F prime has coordinates -4, +4. However, on the object, the coordinates were -4, -4. So we see that the coordinates themselves do not change, but the y value in this case, which was negative, became positive. And that would be the case for all 4 points because they all contain a negative y value. We will now be looking at reflecting in the y-axis. We will be using triangle ABC for that example. As was previously done, triangle ABC has coordinates of point A being 2, 2, point B 3, 5, and point C 6, 3. We will be working on reflecting triangle ABC in the y-axis. Taking point A, we will measure the distance of point A from the y-axis, which is the mirror line. As can be seen, point A is 1, 2 units away from the mirror line, so we will count 1, 2 units in the opposite direction to obtain point A prime. Taking point B, we will measure its distance from the y-axis, which is 1, 2, 3 units. So from the x-axis or mirror line, we will count 1, 2, 3 units, and that will give us our B prime. Taking point C, we will count 1, 2, 3, 4, 5, 6 units up to the mirror line. So we'll count 1, 2, 3, 4, 5, 6 units away from the mirror line. And that will give us our C prime. Then I will connect the dots, the points or vertices on our triangle. So there we have the image of triangle ABC, and we will now record the coordinates of each point. Point A has coordinates -2, 1. Point B prime has coordinates -3, 5. C prime has coordinates -6, 3. And we have completed our question.